Hello everyone, welcome to Coding Boots. So in this video, we are going to discuss about the role of Apache Zookeeper in a Kafka cluster. So we have discussed about Kafka architecture and the installation of a simple Kafka cluster for development practice in the previous videos. So in that architecture, you might have noticed an additional component called Zookeeper. So we have not explained in detail. So I have explained theoretically what is the role of a Zookeeper in that video, but I am going to show you practically how the Zookeeper performs its duties in a Kafka cluster. Okay. So before getting into the practical part, I'll just give a brief overview of or introduction about Zookeeper. Okay. So I have covered a detailed overview and internal or maybe the internal explanation of Zookeeper in one of my previous videos. You can go and watch that if you want to get into detail, but I'll give a high level summary of what a Zookeeper performs in a distributed system. Okay, so as the name says, Zookeeper. Okay, Zookeeper means a person who manages zoo, right? Zoo is a set of different type of, basically it's a place where different animals are kept, right, or maintained. So similarly, Zookeeper, the role is basically coordination and synchronization management. Okay, so this is not just made for a particular software, it's made for any distributed system. Okay, so management of a distributed system is very difficult because nowadays if you see, distributed system means it's not just one or two nodes, it can be hundreds or thousands of components. So the service that manages this distributed system need to also scale horizontally based on the size of the distributed system. So Zookeeper is such a kind of application that can scale to any number of size. So it's basically a horizontally scalable system where we can cluster it, add nodes, okay, and it has fault tolerance and it has much more capabilities. So some of the key activities that are performed by a Zookeeper in a distributed system are, so one is like configuration management. Okay, so if you see, managing configurations up to date. So if you maintain, let's say if you are maintaining let's say train time. Okay, so if I am giving, let's say, paper based train time to everyone, what will happen if there is an update in the train time? So consider the paper based train time or train timetable as the configuration. Okay, so that is there with everyone. See, if the train time changes, then the local configuration or the local paper based timetable will not be up to date, right? So but let's say if I am keeping in a central location instead of like maintaining a paper, if I am keeping a digitally managed central timetable which can be accessed by everyone, what will happen? So then if I update it at one place, it will be up to date with everyone, right? So in case of distributed system, that's the case. Sometimes the various parties in a distributed system might not interact each other. It might interact through a third party, okay, a third party or a middleman. So Zookeeper acts as a middleman in such cases. Okay, so that means a person A and person B doesn't need to interact each other. So it can interact with the middleman and basically do the activities. So that's why management of configuration is one of the activity that Zookeeper performs. Okay, it acts as a single central source of truth for all the configurations. Second thing is leader election. Leader election means, let's say in a distributed system, so managing the leaders. Okay, leader means every system, every group of or any group needs a leader, right? So it can be either a team lead or a manager. So if that role is not there, what will happen? The coordination is not going to, or the task allocation, the work, it's not going to be efficient. So Zookeeper maintains the details of the leader so that every worker will know who is the leader. So let's say if the leader basically because of some reason the leader service gets stopped, or if the leader node goes down or something, the new leader election will happen immediately. The new leader details will be updated in the Zookeeper. So leader election, leader management, these activities will be one of the activities. Okay, it's not, I'm not talking about just Kafka. It can be Kafka or any other system. Some of the things that use a Zookeeper are Apache HBase, or Apache Storm. And if you see, there are so many other services within the Hadoop ecosystem that use the Zookeeper. So it's not just limited to Hadoop or Kafka or anything. Okay, so even your custom applications, when you build, you can use Zookeeper for some of these management, configuration management or state management, or like maybe token management, baton management. So many things you can use. Okay. So then next is like logs, managing logs in the distributed system. Let's say like it is let's say you are going to basically access something, so you don't want anyone else to access that while you access it. So what you can do, you can maintain, or you can say I am using it, so I am locking it. You can just put your card over there, or you can just record your state in the Zookeeper and say anyone else, you have to refer this particular section before you access this. So when they access or when they verify with Zookeeper, what will happen? They will say, okay, somebody else is already using, you cannot use it right now, so wait for the person to finish the activity. So in this way we can manage lock. So here also Zookeeper will act as the middleman, okay, like a librarian. So then next is like the cluster management. So the membership management in a cluster. Let's say when a new party joins a cluster means, think about like a Hadoop cluster, or not Hadoop cluster, think about a Kafka cluster. So when a new node gets added to the cluster, it will get registered. First, the new node needs the details of the existing cluster, so that will get pulled from the Zookeeper. Second is the details of the new node need to get registered, that also get registered in the Zookeeper. And the health of the cluster, let's say like if a cluster a node, if a node is not in contact for some time, we need to remove the node from further task allocations, right? So how will other node knows whether a node is like not in touch for or beyond a certain number of or certain seconds? So that all those kind of statistics will be maintained in the Zookeeper, so that other node will know who all are active in the cluster and who all can take part in any of the task execution. So that is what membership management. So it maintains track of all the node that joins, leaves, in touch, out of contact, all those kind of things will be maintained in the Zookeeper cluster. Okay, so Zookeeper as explained, so it's not just a single node service. We can run it as a single node service, a very lightweight service, but it can be executed like a cluster as well. Okay, so internally Zookeeper is what? It is just a file system. Okay, it's like a tree like structure file system. So what will happen is, the file system is in memory. That means the latency is very less. Okay, so just like a in-memory cache kind of thing, we can access this file system without a latency. Without means a very minimal latency. Okay, it's not like I'm reading from a disk kind of thing. It is very quick. Okay, then it's clustered. As it is clustered, even if the node failure happens in a Zookeeper cluster, it can still maintain failures up to a number based on the number of nodes. Okay, so and if you see the diagram below, so this is how the file system looks like. It is something similar to a Linux file system, so where we have like a tree structure. Okay, so this we call it as Z nodes. So Z node, it's basically it's a kind of a namespace. Okay, so where it's the file structure or the system is maintained in a hierarchical way. Okay, it maintains a hierarchy. If you see slash, after that we have slash app1, app2, under app1. So what these individual nodes can do is, it can have subdirectories. Also individual nodes can store data as well. Okay, so that means app1 slash app1 can store some data. Okay, also it can have sub nodes like app1 p1, app1 p2, app1 p3. Similarly app2, under that also we can have sub structures. Okay, so this can be scaled to any size, and basically there are a set of APIs. So CLI is also available. There are set of APIs available to interact with this. It's a very simple API. So this API can be used across any other applications to interact with this. So they can create their own file system to store the metadata. Okay, now let's come to the specific case of Kafka. Okay, so In Kafka, as discussed, it's doing distributed coordination and synchronization service. Okay, so it takes care of managing the metadata, managing the leader election, and also it keeps a track of basically the consumption progress. Okay, consumption progress, how it will keep a track. Basically, the offset management is maintained in Zookeeper. Okay, so Zookeeper, so like I mean, as part of this, what happens? Zookeeper maintains a track of the brokers which are part of the Kafka cluster. Zookeeper, okay, and also like I mean, it knows so the leaders. Okay, so which broker is the leader for a given partition under a given topic. Okay, so the leader in a Zookeeper, no, leader in a Kafka is maintained. I mean, is at the partition level. Okay, so which broker is the leader of a given partition, all this information is stored in Zookeeper. Okay, so then basically the details of the topics, configurations, permissions, everything is managed in Zookeeper. Also like I mean any configuration changes, right? So like I mean, or configuration changes or addition of a new topic, deletion of a topic, addition of a new, if a member joins a Kafka cluster, if a member goes out of contact, all those information are stored in Zookeeper. Okay, so this is how in a typical Kafka cluster the communication is maintained. Okay, the Kafka brokers, if you take the configuration of any Kafka broker, you won't see the details of other Kafka brokers. Okay, the only thing that you will see is the configuration of Zookeeper. Okay, so that means every Kafka broker has the details of Zookeeper, and what it will do, Kafka will interact with Zookeeper, fetch the data, identify other brokers. Okay, that is how it happens. So that even if this second broker goes away, it doesn't matter. Okay, so Kafka will again contact Zookeeper. Zookeeper says, okay, there is one more broker available, this is the guy. Okay, so that means I mean there is no direct interaction between brokers without basically there is no direct means unless before contacting Zookeeper it won't make, or the brokers won't do one-to-one communication. It's always first it will check with Zookeeper who is active, then only the direct interactions will happen. There is no other interaction without checking with Zookeeper. Okay, so that means that's why it need a very low latent file system or low latent system, because in case of a large system where we have thousands of nodes, then there will be several thousands of requests hitting the Zookeeper every second. Okay, because it's not just as part of every operation like leader health, or when the data transfer happens, consumer data or topic data, so other configuration management, everything, right? So as part of all these there will be so many requests hitting Zookeeper, so it needs a low latent file system. Okay, so that is why it is all kept in memory. Okay, in memory means it doesn't have to read from the disk every time. Okay, so now let's get into the configuration of Zookeeper. So before getting into the configuration of Zookeeper, I'll show you the configuration of Kafka. So let's see. So this is the configuration of a Kafka. Okay, server.properties. Okay, so if you see here, if you see this configuration, okay, this has the broker ID. So this is the the current broker configuration. Listener also, it is the current broker configuration. It is not configuring anything about the remaining brokers. It's only the current local configuration. This is the data directory configuration. Okay, so if you come down, it doesn't have any configuration related to the remaining brokers. But here if you see, there is zookeeper.connect. Okay, so here I have configured localhost because my Zookeeper is running on the same machine. But in case of a clustered setup, or in case of a production grade cluster, we'll have to specify a quorum of Zookeeper. Quorum means basically like this. Okay, so here it is all 127, but it is not 127. We'll have to give the host name or IP address, colon port, comma, and IP address of the next colon port, comma, like that. We can give comma separated host port pairs of the Zookeeper cluster. Okay, not just one, multiple nodes. Okay, so this is the only configuration that enables the brokers to continue or discover other brokers. Okay, so that is what we have in the Kafka configuration. Now what we will do is, there is a file system of Zookeeper. Okay, file system of Zookeeper. Let's see what is getting stored inside the file system of Zookeeper. So in in this one there is something called Zookeeper shell. Okay, Zookeeper shell so I will have to use the Zookeeper host and port. So by default Zookeeper runs in 2181 port. Let's see, let's enter the shell. Okay, so this is the command line, and now you see connected to 2181. Welcome to Zookeeper. If the connection is successful, it shows welcome to Zookeeper. Now let's do simple commands. Okay, ls slash, I'm just doing an ls on the base path slash. You see there are so many nodes under this, right? Admin, brokers, clusters, config, consumers, controller, epoch, feature, all these, okay, except the Zookeeper, it's all related to Kafka. Okay, so if you just start a Zookeeper, a plain Zookeeper, you won't see any of these. Okay, because this is I mean at present you are able to see this because right now I have a Kafka cluster running, Kafka running. That's why you are seeing all these. So let's search across ls slash brokers. Okay, so you see brokers, under that we have again nodes, IDs, sequence SQID, topics. Okay, let's see whether we have something written in broker. Get broker, nothing is there. Get, okay, or wait, ls slash brokers as IDs. Okay, you see there is something 0. There is a broker ID 0, because if you see our Kafka configuration, our current broker ID is 0, right? So let us see what is there in the broker ID 0 slash 0. Okay, see this has a JSON. Okay, that means this has the details of the broker 0. If it is a multi-node Kafka, you will see a list of brokers under this, okay, with the IDs of individual brokers. So here I have only one node, that's why you are seeing only one. You see the listener security protocol map, okay, then the host, port, okay, timestamp, okay, all those information are stored here. Okay, so this is what, wait, okay, so this is what I mean. You can see for a specific broker. Now let's see, there is something called broker slash topics, right? Get, oh no, let's list it. Let's brokers slash topics. Okay, you see consumer offset, this is basically the topic that stores the consumer offset, and test01, this is some topic that I have created. Okay, consumer offset is getting created internally. It maintains the offset details of consumers. Okay, test01, let's see what happens under test, sorry. Okay, so it has partitions. Okay, so get test01. Okay, first thing I just did a get of test01. You see there is a topic ID. It has a topic name is the label. Topic ID is there. Replica, removing replica, version. Okay, partitions. All those information are present under this. Okay. So then test0 slash partitions. Okay. So there are no partitions under this topic. Now similarly, if you see cluster is there, get slash cluster. What? Let's see what it is. Okay, ls slash cluster. Okay, there is cluster ID is there, ls slash cluster slash ID. Okay, so it is empty. Let's see get cluster ID. You see this is the cluster ID of our current Kafka cluster. Okay, so this you can verify even from the Kafka broker as well, because the broker configuration inside the broker under the Kafka temp you will see similar cluster ID over there. Every broker will have the same cluster ID. Every broker part of the Kafka cluster will have the same cluster ID maintained. Okay, this is basically what makes them join together. Similarly, if you see, there are so many other configurations here. So all those configurations we can basically navigate it through this simple CLI. Okay, So there are ways to basically create this inode everything. So you can create it based on your need, you can write data based on your need. So it's all possible. Okay, so for you to understand in detail, just time in Google. So if you just open Zookeeper, so you will see create is there, delete is there, exist, get data, set data, get children, sing. There are like so many. It's only simple things. Okay, create, delete. Okay, so create means it creates an inode. Okay, so maybe like we'll try create slash data. Okay, you see now ls slash, there is something data. Yeah, this is what we created, right? So similarly, like delete a node. If I do delete that slash data, it basically deletes it. Maybe like let me set slash data. Okay, so path data, right? So set slash data version. Okay, now let's get from data, get slash data. You see get slash data, you can see version 1. So whatever I am setting, I am able to retrieve it from there as well. Okay, so now delete slash data. Okay, you will see data gets deleted. Now ls slash, you won't see data over here. So the same thing I can do it programmatically as well. I have Python API, Java API, so I can interact with the Zookeeper through various interfaces. So I hope this example is clear. So I think this file system explains the internal role of Zookeeper within a Kafka. So this helps you to, I hope you are clear with how Zookeeper is maintaining the configuration, metadata, the internal management, everything. So if you have any questions or queries, feel free to comment below this video. I'll definitely respond back. So I hope this is clear. Thank you for watching this video.